Hi, I'm so happy to be here. I've been here for a week because I was here last week for the Ruby conference too. My first plan was I was going to fly out this weekend, then fly home for 3 days, and then fly back. And by the time I got here, I realized what a bad plan that was. So I just stayed, and I've had a wonderful week in Amsterdam. So I'm going to talk about a lot of stuff, kind of clustered around observability. If you don't know who I am, my name is Charity. I am the co-founder of Honeycomb. Yes. I'm the co-author of Database Reliability Engineering, and if you have the book, you might have noticed that it's shipped with a horse on the cover. I have unicorn stickers to fix it, so if you need one, let me know. You can't have a mythical creature on the cover of your O'Reilly book. Who knew? But my past is like firmly in operations. Like I've been an ops engineer since I've been on call since I was 17, which is why this is my approach to software. The only good diff is a red diff. Seriously, I feel like it takes junior engineers ship features and senior engineers kill features. So a short partial list of the things that I would like to talk about in this talk. Testing does not mean what you think it means. Go on. If anyone really wants to keep me here all day, just get me started in AI ops. But first, let's go back to how did we get here, and where are we? Well, historically, how many of you have heard of the 3 pillars of observability? Not many of you? Good. It is bullshit. Wait, can I curse? Am I going to get in trouble? Sorry. Oh, thank God. The RubyConf, they were sweethearts, but my first sentence out the gate, I was like, this fucking thing, and they were just like, oh, and I went, oh, wow. Ooh, usually it's okay in Europe. I feel safe here. 3 pillars, so a lot of other vendors are coming out, and they're like, there are 3 pillars of observability, metrics, logs, and tracing, which just so happen to be the 3 categories of products that they're trying to sell you. Probably a coincidence. Monitoring is a cluster of products, your graphites, your Datadogs, where it's all centered around the concept of the metric, which is a single number to which you can append some strings for tags for slicing and dicing. It's super high performing and super terrible for debugging because you lose all the context. You've stripped away all the context at the time of write, and you're pre-aggregating up front. And then we've got logs, which which are where data goes to die. Strings strings have no place in modern engineering. It's structure your data or die. But it's useful for, I guess, compliance reasons sometimes. And then more recently, we've got APM, which is you install a library or something in your code, and it reports, this is a shift from the third-person narrative, where you've got an agent that's checking up on a piece of code, how you doing, right? And now it's the code itself is reporting back to you, here's what I'm experiencing the world to be. It's a more reliable perspective because it's coming to you firsthand. It's not completely reliable because it's still computers, but, and tracing, honestly, should just be thought of as a visualization layer, right? It's just a way of visualizing things in order, which is helpful to us as human beings to see where things are taking a long time. Cool. Now that we've had that primer, what do we need to get to where we're going? Well, honestly, I think that it's bigger than that. This is not just about observability or monitoring or understanding how the systems work. This is about a fundamental revolution to the way that we develop and ship software. Because it sucks. Because it's very error-prone, and it does not lead to reliable systems, and just as importantly, it burns out people. It is really, really hard to anybody who's on call trying to maintain one of these 24/7 available services. We think of deploys as being a switch that we flip, right? Your blue-green deploys, or whatever. You flip from one version to the other. But the first lesson is deploying code is not a binary switch. It is the initiation of a process. It's more of one step in a long process of gaining confidence in your code. How many of you here write some code, put it in prod, and immediately trust it? Of course you don't. You're DevOps. You know better than that. We think of it as a continuum, right? The world that exists in managers' minds is often, it's on or it's off. Development, and then you're in prod. Those of us who do deploys in the regular think of it much more like a process where we've got, continuous deployments, rolling releases. We've probably got some rollbacks, maybe some cherry picks or some feature flags. Some things don't always go exactly as planned. And then at some point, somebody's like, why don't we add chaos engineering? Well, part of this is a very good, it's a very good step towards recognizing that the development process has to extend way into production, right? There's no bright lines here. And the production engineering actually has to extend way back into development. This is why we get our code into production as fast as we can. Have you guys read the Dora report, the DevOps report? Okay, if you haven't read it, you should totally read it. It's the report that Jez Humble and Nora, I forget her name. Yes. They wrote about, basically they're trying to systematically survey engineering teams to figure out what makes a good one, right? What are the markers of a healthy engineering team? And it turns out almost everything that we think of as being important doesn't matter. The one thing that predictably says whether a team is good or not is just how quickly after they write code does it get into production. And it's great because you can go look your team up and see where you are. Are you in the top 1.5% of all teams? You can find out. And I think it's really important that we start to apply some science to this because, well, things are getting harder. I'm a music major. I'm not actually an engineer by trade, which is why when I draw graphs, they often look like this. But I have a graph, so you know it's true. But complexity is going up, right? We all know this intuitively. And the science does back it up, although I didn't bother to do any. It is getting harder. Here, let's look at some graphs we can't understand. There's the lamp stack, the humble lamp stack, right? Your load balancer, your web server, your app server, and your database. And first of all, if you can solve your problems using a lamp stack, please do so. Please do so. It's such a beautiful piece of technology to run. You just look at any dashboard and you immediately know what the problem is. It's fantastic. Unfortunately for most of us, we can no longer do that, right? We've got systems that look somewhat more like this is a diagram of the last infrastructure I built before Honeycomb, which is Parse, mobile backend as a service. That middle cloud is a few hundred MongoDB replica sets. We just let developers all over the world upload their own JavaScript code, and I just had to make it work and write their own queries, upload them to my database, my precious database, and I just had to make them work. The cotenancy problems alone was, and this is a system that loops back into itself. So any single node there could, in theory, infect the latency of the entire thing. So, fun. But it gets worse. This is the national electrical grid of my country. And increasingly, this is the kind of system you should have in your head when you're designing, when you're building, when you're operating, when you're trying to think about how to understand it. Because you cannot look at a dashboard and understand immediately where the problem is. Some problems are going to be hyper-local, right? Some problems you can only see if you zoom all the way into a small town in Iowa where an oak tree fell over on Main Street and took down a power line, right? You can't predict it. You really shouldn't waste any time trying to predict it. You just need to build in resiliency and make it so that you can quickly slice and dice and triage the problem, get it fixed, and hopefully route around it in the meantime, right? So that's one type of problem. Some problems are the exact opposite. You can only see them if you zoom way out and get a bird's eye view. Or maybe you can't even see it. An example I like to use is if all of the bolts that you ordered in 1972 happen to be rusting 10 times as fast, and they need to be proactively replaced. How are you going to monitor for that? You just can't, right? You kind of have to give up and just invest in observability so that you can detect it, remediate it, et cetera. And these kinds of systems have a lot of other implications. This kind of system, it's very easy for you to just automate the infrastructure and spin up a copy every single time you want to test something. Spin it up, tear it down. Awesome. Working at, I put Facebook logo up there because that's the system I was working. They do not spin up a copy. They couldn't if they wanted to. It would be cost prohibitive if they did. And more importantly, it's so you have mostly system, predict how it's going to fail, write some monitoring checks, and learn the rest over the next year or so. That kind of system basically doesn't really exist anymore for most of us. And the shift is to a system where it's mostly unknown unknowns, where you can't predict most of the things that are going to happen. Or rather, you have automated away all of the things where you would get paged and go, oh, that again, oh, that again. No, that's something all the time. So you fixed it, right? Or you're dead. I don't know. Or you're just like hiring armies of meat servants to like send into the grinder, but hopefully you're not doing that. Hopefully you've automated it, right? The problems that you're left with, every time you get paged, you should go, huh, that's new, right? Anytime you get paged, it should be an engineering problem, not a support problem, because the support load is just too much to manage. And with these unknown unknowns and these distributed systems, we basically have an infinitely long, thin tail of things that almost never happen. Except that one time they will. It's fun. So welcome to, your congratulations. I think this means you get a raise. But a fundamental truth of these systems is that the unknown unknowns will always outstrip the knowns. And distributed systems are especially hostile to being cloned or imitated or monitored. They just have too many characteristics that are special. They have an infinitely long list of almost impossible failure scenarios that make staging environments basically useless. And in fact, staging will turn into a black hole for your engineering time. How many of us have spent days trying to get staging to look like production? Or there's a bug, it's happening in prod, but it's not happening in staging. Why? Has anyone here ever lost a day, a week to that shit? Of course you have. Right? Like, it's so infuriating. Even if you use the exact same hardware, like the gold standard of testing is the capture replay, right? You sniff a day's worth of traffic that's going to your service, and you capture it, and you maybe reconstruct the transactions, and then you replay it in a controlled environment. I know this because I've built that 3 times for 3 different databases. And for databases, it is a worthwhile thing to build, and for almost nothing else. And even then, you'll find that problems that show up in prod won't show up there. And you're just like, why? You don't know. Sometimes problems will show up in some runs of your test. Even if you try and replay all the transactions at exactly the same intervals, there's just too much, there's too much of what is called emergent behaviors, right? That if you try to understand all of them, you will go mad. So don't. But the shift to these systems where they're very distributed, et cetera, it also means that we are way more important than we've ever been. Because operational literacy is no longer a nice to have. Like every single one of your software engineers, how many of you here identify as primarily software engineers? Nice. Well, you are wonderful people for being here, because like I wish all software engineers felt this level of ownership over their own code, because you have to. Because you can no longer rely on someone else to debug it for you and serve up bugs on a nice little silver platter. Also, this is just a pet peeve of mine, so I snuck it in here. Unless you have observability, you don't actually have chaos engineering, you just have chaos. And by observability there, I mean the ability to slice and dice, to understand what's happening in production at a very fine level. If anytime you look at a spike, you can identify what it is within 10 seconds, great. Now you've qualified for chaos engineering in my book. Otherwise, that's not the right place to spend your time. And what is observability? That's a great question. Maybe I should have led with that. Well, it is not the same thing as monitoring. And to prove it, I will quote Gregory, who hates it when I quote him. He gave this great talk at Monitorama a couple years ago called "Monitoring is Dead." And I loved it And he shortly thereafter went to become a VP at a monitoring company. And he really hates it when I quote him on this. But I think his words stand. Monitoring systems have not changed significantly in 20 years, and they've fallen behind the way that we build software. Our software is now these large distributed systems made up of many non-uniform interacting components, while the core functionality of monitoring systems has stagnated. I could not have said it better. Because monitoring is fundamentally a post hoc approach. It is coming along afterwards and dealing with the known unknowns. It's writing checks, right? You all have written Nagios checks, you know. If it returns a 1, do this. If it returns a 0, do that. That's great for the things that you already know about. That's great for like 80% of the old systems. It's great for like 10% of the new systems. So when we were building Honeycomb a couple years ago, it was actually harder to figure out how to talk about what we were doing than it was to build a distributed column store and all of the other query planners and everything. Because all of the terms and data are so overloaded. And people just spray them out. It's really annoying. But I was reading the Wikipedia page for observability. And that's when I found this definition. In control theory, it's a measure of how well you could understand the internal states of a system just by observing it from the outside. And I went, oh my God, that's what we're trying to do. That is exactly what we're trying to do. And if you translate that for software engineering, you know, it's just about, can we gather information at the right level of granularity, the right level of abstraction, and then provide, you know, the right query interface so that no matter what's happening in your system, you can ask the questions, you can understand what's happening without having to ship new code to handle that condition, right? Because that's when you get yourself stuck in this terrible like catch-22 where you can only find what you're looking for, as all of us who have used log aggregations tools know quite well. If you know what you're looking for, you can find it every time, very effectively. If you don't know what you're looking for, fuck, we're gonna be here all day. So, can you answer new questions without shipping new code is my bar of, this is what observability means. And my ordering's a little off there. It also correlates to the shift from the third-party perspective to the first-party perspective. Because you really want to have the most reliable narrator, which is going to be the code itself, reporting. And a lot of other things fall out of this, like you can't do pre-aggregation because anytime you do pre-aggregation or indexing, you are forcing yourself to fit into a world where you've predicted what data is going to be valuable. But I won't bore you with all that stuff. Basically, complexity is exploding everywhere, and our tools are still, I swallowed a frog or something. Yes, water. That's better. Welcome to distributed systems. Yeah, you know, it's not fine at all. Your system is never actually up, is the other lesson. Like, and this can be a hard thing for people to wrap their heads around. We're so used to like, you know, finding bugs and like eliminating them. And the reality is that there are so many things wrong with your system right now. So many things. And it's fine. It's mostly fine, right? You still sleep through the night. This is the power of SLOs, service level objectives, and SLIs, right? The game is not to make it so that nothing breaks. That is not the game. That was the old game and we failed. So new game is make it so that as many things can break as possible before anyone notices. Right? That is absolutely the bar. The bar is, did a user notice that you had a bug or that something was broken? If so, boom, get on that. If not, like, you don't have to operate in crisis mode all the time, right? As long as a user isn't noticing a problem at the level at which you have agreed is, you know, unacceptable, you are free to operate like an engineering team who plans and builds things and does things instead of a reactive firefighter. Yeah, we did that. So, which brings us to testing in production. Lots of people have a visceral reaction to this, which I actually appreciate. I enjoy it. I enjoy their visceral reactions. And I think it's because, like, we all know the meme, you know, the most interesting man in the world. I don't always test, but when I do, I test in production. I love that guy. But he's wrong. Good engineers test in production. Bad engineers also test in production, but they don't admit it, and so they don't do it very well. You have to do it, which means we have to invest in it, right? And when I say that staging is a black hole for engineering time, like 80% of the bugs can be caught with like 20% of the effort there, which means that the rest of the effort we're just like shoveling into like this idea that we can prevent failure, which we can't. So maybe we should take some of those cycles out and put it into guardrails or training. Like every single engineer who has commit privileges, everyone who's allowed to commit to your repository should also know how to ship code, should deploy it, know how to roll it back, should know how to get it to a known good state before they have to escalate. And they should know how to debug in production. Everyone should be knee-deep in production every day. And we, from the ops side, we've often had this kind of territorial stance, like nobody's allowed to have, that's not okay anymore. Because we have built a glass castle, and we should have built a playground, basically. We should have built a place where everyone knows what they're doing and feels literate. I feel like a mark of senior engineers, to me, is that I trust their instincts. We're not going to run on instinct. We're going to stop and unpack it and understand it and get some data and everything. But if a senior engineer who I trust is like, oh, I have a bad feeling about this, I'll stop, right? And we'll figure out what's going on. And then you know how you build those instincts and intuitions? By doing things in production. And the more time you spend in staging, the more time you are actually hurting your ability to build your intuition, because it's not just neutral, it's actually, you're training your machine on a bad corpus of data, right? You're teaching your instincts that it's fine to type drop database blah, whatever you want. You're teaching it that, this type of request runs fast when over here it does not, right? So get it into production as quickly as you can. Spend as much time in production as you can. It doesn't mean you have to give everyone root. You should give everyone the ability to see and understand production through the lens of their instrumentation. This is entirely an instrumentation game. And if you need a tool, I could recommend Honeycomb. But let's try some examples to kind of illustrate the type of debugging that I'm talking about and how it's different than the old way. So here's a problem that I guarantee everyone in this room has tried to debug. Photos are loading slowly for some people. Why? Cool. If we have a lamp stack, here are some of the many known unknowns. Right? And you could have predicted most of these, just you look at your dashboard and you can tell what's going on. So cool. We can monitor these things. These are great things to monitor. Now let's look at the same question from a microservices standpoint. And all of these scenarios, I will add, were taken from real incidents at Parse or Instagram. Cool. So I'm not exactly sure what to monitor for. I've got more. Is this ringing any bells? Not even sure if this is a problem or not. People are complaining, but is it really a bug? Jesus, I could do this all day, by the way. That first one is my absolute favorite outage of all time. We were running push notifications at Parse, and I don't know if it's still true, but back then Android devices had to connect and leave a connection open for every device so that they could subscribe across the channel. So we would round robin them across a bunch of nodes that were tuned to have lots of connections. And one day we added more capacity to the auto-scaling group. Everything came up, bootstrapped, added itself, blah, blah, blah. And I start hearing Parse, push is down. And I'm like, push is not down. I'm getting push messages, and it's a queue, ergo push is not down. And a day or two goes by, and people are getting very upset. Push is down. I'm like, oh, fine. I went and figured it out. So we had added some more hosts, and the round-robin DNS, was returning a set that had exceeded the UDP packet size. So, which is fine. It's supposed to fail over to TCP, which it was doing everywhere in the world except for one router in Eastern Europe. Again, I ask you, what am I supposed to monitor for? I don't even know. I give up, right? You can't monitor for all these things. You can only declare bankruptcy, accept failure, instrument, make it easy to slice and dice and reduce the search space and explore in real time, right? This is a shift from a very monitoring type of mindset to a debugging mindset. It's very much like attaching your code to a debugger, like setting a breakpoint, just the kind of detail and the exploratory approach. And dashboards, might I add, are absolutely antithetical to this, because a dashboard is an answer. You've got your dashboard on the wall, and it's it is assumed that it knows the question, and here's your answer. And so when we start debugging by flipping through our dashboards, looking to see which answer matches the scenario that we're seeing right now, hate it. Now, I'm not angry at dashboards that are interactive. That is the right way to do it. You should be asking a lot of small questions, going where the breadcrumbs trail takes you. You should not be flipping through a bunch of answers to see which one matches the current scenario. Because not only is that it's going to blind you to things that are not already in your list of scenarios, it's the wrong way of thinking about it. How many of you have ever had a dashboard that rarely gets used, and a couple of sources stopped reporting to it? And how long did it take you to figure that out? Right? You need to be thinking about it from first principles. You need to be debugging. You need to be interacting, having a conversation with your code and your systems, not flipping through dashboards. Anyway. These are all unknown unknowns that may have never happened before, may never happen again. So it's probably not a great use of your time to do the whole thing where you hold a post-mortem, and then you're okay, what dashboards can we create so we'll find this problem immediately the next time? What checks can we write so we can find this immediately the next time? The answer is, it's going to be something else the next time. So invest your time into observability, not into monitoring. And this is the overwhelming majority of what we have to care about for the rest of our lives. Which brings me to the 3 principles of software ownership. They who write the code can and should be able to deploy the code. If it's not being automatically deployed by the robots, I will also accept that answer. And watch it run in production. And be on call for it. Now, watching it run in production. A lot of teams have gotten the message that software engineers need to be on call. And that's awesome. But they only look at it when something's broken. Well, now they have no idea what normal feels like or what normal looks like, right? You don't want to just be looking at it when something's broken. You really want to be interacting with your code every single day. You want to be, I feel like it should be muscle memory. You're shipping something. First of all, you should never accept a pull request if you can't answer the question, how will I know if this breaks, right? I feel like as an industry, we have so much leveling up to do when it comes to instrumentation. And we've been hamstrung by our shitty tools, because we've been teaching to the test. We've been building to suit our tools, not to suit our needs. But in terms of instrumentation, we need to get better at it. But if you just start asking yourself that question, how will I know if this breaks? And then, as it's deploying, go and look, right? Is it doing what I thought it would? Did I write what I thought I wrote? Is it behaving the way I thought it would? Does anything else look weird? When teams start to do that, they catch 80% of all problems before users ever do. And because the feedback loop is tight and virtuous, right? The person who built it is deploying it and is watching it. They know what to look for. They're going to catch it fast. And by catching things fast, you avoid getting yourself into this trap where all of the problems that are happening are things that were created weeks, if not months or years ago, and they take forever to figure out, because nobody has them fresh in their mind, right? Now, I believe that a lot of people I feel like the question of whether or not software engineers should be on call is pretty much a settled question now, but for a long time people got very angry about it, and I understand why. Because we in operations, we have a sordid history of masochism, of treating ourselves like shit, right? Of being woken up in the middle of the night, of giving up our weekends, and poor software engineers are like, God, I don't want to do that. I don't either. I'm over 30. I'm done being woken up in the middle of the night. I am no longer willing to sacrifice my life on the altar of some system, right? The point is not that we're trying to invite software engineers into the misery with us. The point is that this is the way that we make it better. And a lot of people, I feel like, have lost hope. They don't actually believe that their systems can be so good that they would be willing to support them. It can be done, right? Honeycomb engineers are on call, and like all of them, even the front-end folks are on call in the rotation. And like any time that someone gets woken up or paged, like we treat it as an emergency. This is a heart attack. This is not diabetes, right? We fix it so that it doesn't get to that point. And it's not just us. Like I know of a lot of teams who not just the fresh ones, who are starting out and don't have all this accumulated legacy stuff. That it's pretty easy for this to go, yeah, those people can do it, right? They don't have the stuff. I know of teams who have dug themselves out of this hole, and it is now not, on-call is not something they have to plan their lives around. On-call is not something that's life-impacting. On-call is not something that interferes with your sleep. It is possible to have systems that behave themselves. All it takes is those tight, virtuous feedback loops of the people who write the code are the ones who are debugging it. You find and fix as quickly as possible. You get used to looking at your code in production so you really understand it. And then management support needs to, carve out enough contiguous time to actually go back and fix shit, not just make forward progress on products. That's the other key thing. And how many managers are here for me to yell at? Okay, well, there's 3, and I'm going to yell anyway. If you don't give your people air cover, you do not have the moral authority to put them on call. Period. Sorry to gang up on y'all like that. But I have put, over the course of my career, I have put software engineers on call successfully and unsuccessfully, and sometimes unsuccessfully and then successfully, or vice versa. And the difference has never been the engineer's willingness. The teams have always been, very willing. I've been very fortunate. The cause has been an observability gap. When it has failed, it has been because I've taken this team of software engineers and I've given them a bunch of ops tools and I've been like, go. Well, okay. Software engineers spend their days, looking at, endpoints and variables and service names and stuff. And then we give them ops tools that are like uptime percentage and like free memory. And it's just like, most software engineers, the exceptional ones, can bridge that gap, but most software engineers are just like they're in a foreign land now, and they don't actually know how to bridge, they don't know how to interpret these dashboards to answer the questions that they have with this code. And that's valid. I actually have a lot of sympathy for that, which is part of why we built Honeycomb, because it didn't really exist. And I'm not trying to give a product pitch, I'm just like, I'm just trying to acknowledge it can be very difficult. But when you have a healthy team who's very morally invested in their code being good, when it fails, it's usually because they don't have the right tools. Tools are important. I guess I already went on this rant, but we do spend too much time looking at our code in elaborately falsified environments and not enough time looking at it in the real world where it counts. But like code that is not being used by users is dead code. Like it doesn't matter. You don't get partial credit for it. And I feel the same way about staging environments and other non-production environments. They don't matter. The time that we spend there is dead time. And I'm being a little hyperbolic about this. Some of you have very good reasons to have staging environments, but I would question the amount of time that you commit to them compared to the time that you commit to your production tooling. Like, are you starving the beast? Because we all have a limited number of engineering cycles. It's just a fact. So whenever we choose to spend some cycles on one thing, we're implicitly saying that all these other things are less valuable. And almost every team that I've ever seen has been systematically starving production of those cycles. So observability for software engineers in the future, like these are the characteristics of tooling that will get you where you need to go. Arbitrarily wide, structured data blobs that contain all of the context for the request being passed along throughout. I forgot to link. This is a great talk by Bo Liddon. I will tweet it out after the event. Look for it, because every one of you should watch it. It's amazing. Dude has hella experience. He's really great. And it's really funny, too. High cardinality is no longer a nice to have. And when I say cardinality, I mean, imagine you have like 100 million users. The highest cardinality dimensions will be anything with a unique ID, like unique request ID, whatever. High cardinality, but slightly less high, would be like first name, last name. Low cardinality dimension is typically gender, and lowest of all is species equals human, right? So, like, clearly when you're debugging, it's the high cardinality dimensions that you care about the most because they're the most identifying. So any tool that doesn't have high cardinality support, just not going to get you where you need to go. And sampling. If you run at scale, you will have to do the trade-off between sampling and aggregating. And aggregation is great for historical trends and for operational stuff. Sampling is great for debugging and software engineering. Watch it run in production, accept no substitute. Get used to observing your systems when they're not on fire. And watch it when it's running with real data, real users, the whole shebang. The health of the system doesn't really matter anymore, honestly. You care about the trees, not the forest. If you're running on AWS and you've done your job correctly, as I'm sure you have, and if an AZ goes down, you don't have to care. A third of your network can be down, and you shouldn't have to get woken up, right? You don't care about the health of the system. You care about the ability of every single request to execute and get the resources that it needs. Because users don't care about what your system health is, too. Like, spoiler alert, users do not give a fuck. And I have a bunch of stickers that will attest to this that I will share with you after this. Users care about their experience. That's all they care about. And for too long, our tooling has emphasized the abstract idea of the system over the real lived experience of the user. So, to recap, what you win in exchange for going through all this pain and suffering, changing tooling, all this shit, what you win is dramatically fewer paging alerts. You should be able to delete like almost all of them, because most of them have just been this hacked together shit to help you deal with the fact that you haven't been able to debug in a reasonable amount of time. So you rely on this like a very elaborate like ecosystem of paging alerts to try and triage what's going on. Oh my God, just stop. Like if you have a tool that lets you debug in real time, you could delete everything except for per service, latency, requests, and errors, maybe saturation, and some end-to-end checks that traverse your key code paths, the ones that make you money, right? That's it. Sleep through the night for everything else. And do your SLOs. And that's the end. Thank you. Are we doing questions? Yeah, let's do questions.
Okay, does anybody have any questions for Charity? Okay, again, heads up, I'm not very good at throwing this thing, so watch out. Ooh. I thought I saw a question there.
Nice.
Sorry, please pass it along.
The hell is it? Microphone.
So you can speak into the box so that...
This is amazing. It's the first time I've used it. So you speak about observability, and do you think it's like an on-off where you say that we need observability, or is it a scale? And if it's a scale, can you quantify if you can reach like 60, 70% observability so you know you're in the green zone?
Oh, that's a good question. So what it really comes down to is, how many of the things that happen in your system can you understand? So if in a normal week, like every time you need to ask a question of your system, within, say 2 or 3 minutes, you've got an answer. And like, it doesn't have to engage like your hard problem-solving brain. It's just, then I think that you could say that you're good. Because this is a human problem, right? I feel like too often we try to make these math problems instead of human problems. It doesn't matter like how perfect your tooling is if your humans can't figure it out, right? And it doesn't matter how bad your tooling is if you're doing great, right? If life is good for the people who are running the systems, if they've got the information they need, that's really what I care about. Now, I'm speaking mostly to people who are running, pretty large, complicated systems, where they've had to offload a lot of this to other teams. Honestly, they've had to hire other teams, and if that's what you're doing, then it doesn't count that your life is good, right? But yeah, it's just about can you slice and dice? Can you figure out complex things that are happening in your systems quickly?
Okay.
Any other questions? Nope.
There's one.
Oh, can you please throw the mic?
Woo!
Whoa, you're a lot better at this than I am.
Would you say that using logs would be one way of obtaining observability?
So it can be done with logs, absolutely. What you will want is them to be arbitrarily wide, because so much of debugging is picking out outliers, and when you have a bunch of requests that are erroring, what outliers do they have in common, right? And so unless you've structured your data such that you have a lot of context for the request at every hop, you're going to find it very difficult to do that. But if you could totally do this by when a request enters a service, you should initialize an empty blob, right? And pre-populate it with everything that you know about, any parameters that were passed in, anything about the language runtime, the environment, anything you know, pre-populate it. And then while the request is executing in that service, you just plop in any unique IDs, any request ID, traces, trace IDs with an incrementer, anything that you think is meaningful, shopping cart IDs, right? Anything that you're I'm going to need to know this, or this is going to be useful for debugging. Just push that in. And then at the end of the request in that service, if you write out that one log line and then stuff that in the store, that will get you good observability. Yes, because you'll be able to there's a spike. Okay, so sort out the 500s. Okay, so you can start using your tools to figure out, these 5 things had to go wrong in order for these errors to happen, that sort of thing. But that's the shape of the solution.
Anyone else?
Nope.
Right there.
Here, okay. I have a question about front-end testing. I think everybody that does front-end testing here, maybe is not even here, because I don't know anybody really that does proper front-end testing.
Yeah.
But can we get rid of that using these kind of tools?
Can you get rid of it?
Can it be replaced then?
Depends on what you mean by front-end testing. People do use Honeycomb for a lot of stuff, for the front end, yes. In fact, my engineering manager, Emily, is from the front end, and she has given talks about how to do this correctly. If you hit me up afterwards, I will try and get you one of those. If you're asking me front-end questions, you're kind of going to the wrong shop. What is JavaScript? I'm not even sure. Pixels. Pixels are nice. I know. Nobody wants to know more about what it takes to be a senior software engineer? All right, I'm going to answer a question that nobody asked, which is that I feel very strongly, all right, managers, there's 3 of you in the room, I feel very strongly that nobody should be promoted to the level of senior engineer unless they've proven that they can own their code in production, period. Right? And I also feel like we need to be very careful what we praise people for, because we tend to praise people for their heroics, but whatever you're praising a team for, you're going to get more of it, right? So maybe instead of praising people for being up all night or whatever, we need to be very careful to not do that and praise people for, getting, shit in early, for not having to, I feel like one of the jobs, not just of management, but of senior engineers, to notice and surface the things that are not naturally noticeable and tech debt that's going to be amortized over time is way less noticeable than, a sharp pain right now. And so we have to surface it it so that leadership can make good decisions. Likewise, it's our job to notice when people have done their job well and nothing broke, right? It's way harder to notice when nothing broke, when things were done well. But we need to notice that and praise people for doing the things that they're doing very well. And then management needs to make sure that the things we praise people for are in alignment with the things that we promote people for. And that's why we get happy teams.
Thank you so much, Charity.
Thanks.
Thank you so much for speaking with us.
Thank you for having me.